Thank you. I'll stand over here. Good morning, everyone. I know it's bright and early, so thank you for coming out. I actually recommend the talk happening in Hall 1 if you get bored halfway through. But today, we are talking about prices, not priced in, avoiding footguns with price data. I'm going to start with the world's fastest intro. I'm an engineer. I do security at yAudit, Y Academy. Next. If you want the slides, you can scan the QR code, but if you scan the QR code, I know you're not in security. You should manually type the URL, because that's what paranoid people do. Moving on, we'll get back to this at the end. Everyone here knows what DeFi is, decentralized finance. The year is 2024, and DeFi deals with assets and asset prices. Everything needs asset price data, and that should be easy, because it's 2024, right? Right? No. Now, for normies, for what we call normies, which would be the people in this room, very different than your average normies, you might check price data on CoinGecko, on CoinMarketCap, and it looks straightforward. You've got an asset, a number, and some other information about these asset prices. It's easy, right? I'd like to remind everyone that not everyone puts all of their money on chain. Now, I know you love your NFT collection, but I'm going to use a reference from outside the blockchain world just as a, to ground everyone in reality a little bit here. Everyone's favorite stock, coin for Coinbase. I just want to highlight the circles, red circles, showing the day range of the stock price. We have a low price and high price. And it might be hard to see because the font is a bit small on these slides, but the numbers are the same on 3 different websites. I forget which websites exactly, but these are just 3 different financial data websites, and they all match. This makes sense, doesn't it? Now, let's return to our funny little blockchain world, and let's look at Bitcoin. If we open different websites, we look at the same information of the 24-hour low and the 24-hour high. They don't match. This is different than what we just saw on the previous slide with the stock data. And this is interesting, right? Because when you think of a price of an asset, you think of one price. You don't think of multiple prices. But what we're seeing here is that maybe there is no one price that everyone is agreeing on. And this is strange. Everyone needs price data. It's easy, right? You may know about Oracle services like Chainlink, and if you open the Chainlink website, you look at the Bitcoin price feed with USD or USDC, you'll see something like this, showing all these data sources and the prices of these data sources, and there will also be a single number that's the final result that Chainlink provides. Everyone likes the easy life of just seeing one result. But if you look underneath and you use your telescopic vision to see the small font of all these numbers, you will see these numbers do not match. So once again, we're not even talking about the 24-hour high and the low. This is just a random time of day that I open the website and the numbers don't match. It's interesting. We don't have a single price here either, but Chainlink provides one. One of the reasons for this is simply that the liquidity is fractured in DeFi. In traditional finance, if you are placing an order for a stock, there is a more centralized order flow going through the stock market, whereas in DeFi, if you are placing your order on Coinbase, you're going to be interacting with the liquidity on Coinbase. If you go to Kraken, you'll be interacting with the liquidity there. And all of these liquidity sources are fractured, they're separated. There's no single point at which you pass to access all of them. This is decentralized finance, after all. Now, I'd like to just say that this is an underexplored topic, the differences between how the pricing works in traditional finance and DeFi. The day I was making these slides, there was some new research published from Chaos Labs, so I just want to do a quick shout out. Nice work, guys. And this website, with the link at the bottom, which again, you should type manually, shows price differences, price charts between different centralized exchanges, and I think even some decentralized exchanges. So you can actually look at these price differences that I just described. But again, this is underexplored, and this research was just published 1 or 2 weeks ago. There's a few other differences between traditional finance and decentralized finance, as you probably know. But just to highlight quickly before we dive deeper into prices, in DeFi, the markets are open all the time. There is no market close. This does make things a little bit harder. All the trading venues in DeFi have separated fractured liquidity, as I mentioned. The liquidity on Uniswap is totally separate from the liquidity on Coinbase. And the fractured liquidity means lower effective liquidity. And what do I mean by this? Let's say the market cap of Bitcoin is, I don't know, $100 billion. If you want to trade $10 billion of Bitcoin, there may be no single place where you can do this. You may have to combine trades in multiple locations to access $10 billion of Bitcoin. So this fractured liquidity does make things harder in some cases and causes more variability in the prices. Lastly, arbitrage. You'll find this everywhere in finance, but in decentralized finance, it's necessary for setting prices. Decentralized exchanges like Uniswap require arbitrage to even set an accurate price, because how else are you going to set the price? You need to have people trading to determine it. But this might all be a review. To actually get price data in DeFi, there are 2 main sources. One is off-chain price sources, also known as oracles. This has some difficulties. You have to trust off-chain sources with an intermediary and some governance. And the off-chain price updates are instant, but they don't get onto the chain instantly. There's a delay. You have the block timing. Okay, you don't want to deal with this stuff. You decide to use on-chain price data. There's some difficulties there. We have manipulation. This can be MEV front-running a trade that's too large, and then your swap price comes in different than expected if you're not using a limit order. And there can just be manipulation of the price data as well. Another problem with the on-chain data sources, if you hard code your protocol to Uniswap, 6 months later, Balancer has more liquidity. You might decide, you know what, I want to change to use Balancer's price data, to use a deeper liquidity pool. So this can change, and this makes life difficult. I've given you a lot of difficult problems in this quick intro, and developers face this very same challenge. Use an on-chain oracle or use an off-chain oracle. Now, the moment you've all been waiting for. How do we get good price data on-chain? I'd like to present my answer. Yeah, that's not what this talk is about. Sorry, that's maybe next year. But even though I don't have a good answer for this question, what I can provide is a quick lesson on how to play Mission Impossible with avoiding footguns with price data. Now I'm going to go through the list of footguns, and hopefully by the end you guys will be masters of avoiding the common mistakes in this space. Now first, let's say you're new to Web3. You're really excited. You're going to make a protocol. It's going to be the best. Going to have #1 TVL numbers, and you decide to use Uniswap's spot price. No. I love this website. It has one single purpose. The URL is, should I use spot price as my oracle? And, well, I won't elaborate on this, but excellent website. Highly recommend reading it. Okay, you get a little smarter. You decide spot price is not ideal. Let's use this TWAP. What is this TWAP? TWAP, or TWAP, I don't even know how it's said. I only read this stuff online. It's the time-weighted average price. And so instead of using a single price at a single point in time, which could be manipulated very easily, the TWAP is using average price. So you don't have to rely on a single point in time. You rely on a longer period of time, which smooths the data. And this looks great. I mean, it's decentralized, it's on-chain, it's a trusted protocol, it's Uniswap. I mean, what can go wrong? I only showed half of the picture, because on the other half, anyone can manipulate this data. The price is delayed because we're using an average price, not the current price. So if there's very high volatility, the average price may not be ideal to use. And Ethereum switching from proof of work to proof of stake, this also caused, let's say, some difficulties around trusting this data. But you decide, before I proceed to the next one, this website is also excellent to understanding the risks of using the TWAP price because there is actually a value with the amount of capital you can use to manipulate this price. And this website is like a calculator to tell you how safe the price data is, how hard it is to manipulate it. But you decide, I don't care. I'm doing this anyway. So you choose the Uniswap TWAP. What can go wrong? Well, I'm just going to use one example. There are many things that could go wrong. But let's say, for whatever reason, you're using the older Uniswap v2 TWAP. And you get this data, which is USDC to ETH TWAP price. And you might think, OK, if I want the price of ETH in USDC, I can just flip this price upside down and invert it. This is how it works, right? Right? Well, you might think that a 0.4 inaccuracy is a minor detail. But I would like to just point out that Uniswap v2 actually has 2 TWAPs in every single pool. One of them for USDC to ETH and one for the inverse. And these are tracked differently in different state variables. And you might wonder why this is and why this graph has 2 lines that are not overlapping. And in brief, without getting into too much detail, average can mean many things. There's geometric mean, there's arithmetic mean, and basically the way Uniswap v2 tracks this is with the arithmetic mean, whereas Uniswap v3 uses a geometric mean. I hope I got the ordering of those right. But yeah, you can see from this equation, basically inverting the data of an average doesn't always work out exactly. So this is perhaps a more minor foot gun than other sources, but it's something to keep in mind. And there is a blog post for more info. But let's say this is all review, and you've decided to skip Uniswap entirely because you know what's happening in DeFi, and you choose Chainlink. It's safer. It's safer from manipulation. You have no issues. You're going to have a happy life. Your protocol is going to flourish. But that was only half the picture because there is governance risk, there's limited assets supported, and you also need to actually check the data. You cannot merely trust that the data you receive is good. So, what do I mean by this? You might think this example would never happen in the real world, but Chainlink has BTC to USD, which is the actual US dollar currency, as well as WBTC to USD. Bitcoin versus wrapped Bitcoin, basically. And you might think, OK, what's the big deal? If I can use one, I can use the other. Now, unfortunately, these assets are a bit different. Wrapped Bitcoin is not always equal to 1 Bitcoin, so choosing the right feed for your purposes is important. On the right half of the screen, we have another example of ETH to USD and USDC to ETH. And USDC is not always equal to 1 USD. So what do I mean by this? Anyone here in DeFi since 2013? Raise of hands. OK, we have a few survivors. Well done. Glad you made it this far. But there was this massive depeg in USDC back in March. And this is a very clear example of when 1 USDC did not equal 1 USD. So again, using the right price feed is important. And even if you think this footgun would never affect you, it's happened, is all I will say. OK, you decide you've got the right price feed. You know which asset you're dealing with. You go to Chainlink, you find the oracle, and wait a minute, what's this? High market risk, medium market risk, new token. What are these values? To be honest, I don't know exactly how these are calculated, but this is merely a demonstration that you cannot say the oracle's on Chainlink and I'm safe. There are different risks associated with these price sources, And to be honest, I don't know who's even heard of the asset on the leftmost example. I don't want to even try to pronounce it, but some of these assets may not be as liquid. They might not have as much liquidity. And so just saying you're using Chainlink is not always the end of the story, shall we say. There is more analysis needed. Chainlink even says what I have just said, which is that ultimately you are responsible. So saying that you are using Chainlink and trusting Chainlink, well, Chainlink is just going to bounce the blame back on you for choosing the oracle that you ended up choosing. So this is, again, a reminder that you can use Uniswap. You have to be satisfied with the pros and cons, or you can use Chainlink or a similar oracle provider, and you have to be familiar with those pros and cons and the risks associated. Chainlink is not like Uniswap in the sense that Uniswap is decentralized and not likely to change on chain. They have designed the system this way. Chainlink has a lot of off-chain components, and it can change. And this slide demonstrates that. You may be using a certain function in your contract, and Chainlink may decide later to deprecate that function. This is not your fault, but it is your fault for not factoring in that one of your dependencies could change later on. So understanding what assumptions you make when you are integrating with price data is crucial to the success of your protocol. So immutability of Uniswap is a pro in that case, but anyway, this is all about pros and cons. There is no perfect answer. Yeah, this can happen to you. It doesn't even matter which oracle provider you're using. At the end of the day, they are a business, and if there is insufficient demand for certain old data feeds, the price feed may disappear. So keep this in mind and factor this in when you're writing code. Make sure that you're compensating for potential changes in the oracle provider. If I may use an example from Web 2, this is from an amazing website that has silly comics about Google. And as you can see, Google is not exactly known for having the longest lifespan of products with all of their deprecated and killed off projects. But don't mind that. Just stare at the unicorn and things are good. Okay, quick intermission here. I do want to clarify that when I use the word Chainlink, I'm not only talking about Chainlink. There are many other oracle providers. I won't even name names, but this list on DeFi Llama actually has a list of 50. I didn't even realize there were that many options in the space. So I am merely saying Chainlink as an abbreviation for listing all 50 options that apparently exist. So the problems here are not specific to Chainlink. It's the class of solutions that are off-chain oracles. So anyway, intermission is now over. Let's resume. Let's say you choose Chainlink. The problem here is when you receive the data is not always good data. You have to verify the data. And if you have no idea what the code here means, that's perfectly all right. Those of you in security, this may look extremely familiar. But when you get data from Chainlink, you have to perform certain checks, because some of these checks are helping you check if the price oracle is deprecated, if the price oracle is even functioning correctly, and if the price has exceeded the max price or the min price. So all of these things, you might think that Chainlink is handling it, but no. The assumption from Chainlink is that you are handling it. So you need to make sure that you read the docs, you integrate properly with any dependencies you have, and getting price data is not the end of the story. Let's say you choose Chainlink. Can you call the oracle outside of a try-catch? Who thinks yes? Who thinks no? Okay, you're all asleep. Anyway, moving on. Why use a try-catch, which is the recommended approach? Because price data is received from a proxy, and this is just how Chainlink is designed. You are querying a proxy contract for the price, and the price is coming from the implementation contract behind the proxy. The implementation logic behind the proxy can change. That is a typo. It should say can, not and. And to prevent a denial of service in your protocol, you need to prepare for an unexpected change of the implementation contract. This can also happen on, let's say, one of the price feeds where it does get deprecated. There may be some big changes to the implementation logic. You're not prepared for it, and the price oracle merely is not working at all. So that is that. And you might think I'm finally done, but there is one more. Let's say you choose Chainlink, but you're on an L2. An L2 functions differently than an L1. If we take Ethereum, for example, there has not been any downtime on Ethereum for quite some time, but L2s, unfortunately, will sometimes have this experience. Chainlink documentation has a solution. If you are on an L2 and you are using Chainlink, you can use the sequencer uptime feeds. But this is very hard to test. If you have ever thought of testing whether your protocol is working right if the sequencer goes down, I honestly don't even know how you'd go about doing it. So at the end of the day, you are just trusting that the explanation here is working and the code that you copy from the docs is good. This could be dangerous. The part I highlighted at the end of this slide, just saying the L2 has not stopped, but it would be unfair to continue providing service on your applications when only a few users can use them. This is a very interesting comment for a space that's supposed to be immutable and always functioning without any roadblocks, shall we say. So anyway, when you're on an L2, considering sequencer downtime is actually a factor when you choose price data. Now, we've covered a lot of Footguns, and hopefully on time. So, just going to run through these very quick. First of all, don't use a spot price from Uniswap. Use a TWAP only when the average price is okay, and it's up to you to determine what okay means, and when the pool has high enough liquidity. If the pool doesn't have high liquidity, that's another issue. Thirdly, don't invert the TWAP, at least for Uniswap v2, if you're using an arithmetic mean. And there are likely other protocols using arithmetic mean. I just haven't gotten around to checking them all. So when you hear average price, you should have a little alarm bell going off in your head. Fourth, use decentralized Oracle feeds with the correct assets because stable coins are not stable. Pegged assets are not always pegged, depending on the pegged asset. Fifth, use safe feeds. Oracle feeds existing is not enough. You have to check the risks associated. Sixth, dodge deprecations. This will just always happen with decentralized oracles, off-chain oracles. Seventh, add proper checks on the data. Eighth, use try-catch. And finally, if you're on an L2, consider sequencer downtime. Well done. You've made it. Your training is now complete, and you can succeed in Mission Impossible with price data. That is all. Thank you. I was crystal clear.
Yeah, thank you for a great talk. Can you tell about your experience? Did you try different kind of oracles? You say there is more than 50 in your experience, or like Chainlink is like monopoly for now that everyone using?
I think Chainlink is the most used or has been, but there are certainly competitors catching up quickly. And there are different models for pulling the data. You can use a push model, a pull model. Personally, I think you should ask someone from an Oracle company because they will shill you on all the little pros and cons. To be honest, when I am looking at code and I see Chainlink is used, usually this is a positive sign, merely because the signal from big protocols like Aave and Compound they are using Chainlink. So you can go with the assumption if the big TVL protocols are using it, then it's okay. But this is highly asset dependent because some of the less common assets will potentially have very large differences depending which Oracle provider you use. I think if you are doing the price of ETH and USDC, then maybe there's less of a difference. But yes, I think that the exact differences, I have not seen any good research analysis on the pros and cons of different off-chain Oracle providers. So this is open research. Anyone here can take that idea.
Thank you. So I'm sorry, I only caught the last bit. I came late, but I don't know if you mentioned. I've seen people use simulate a swap to actually get a price, and as a way of getting a price. I don't know if you've mentioned it in your presentation. Is this a good practice?
Yes, I think this is perfectly fine. Let's say the focus here was more on how to integrate a protocol with a good price data source. I think on the user side, there are many good practices you can do. You can basically just compare different price data sources and different aggregators to see that the price that you are getting from one aggregator is better than another. But this is all dependent on how much time you want to spend as a user actually verifying this. If you're dealing with very large swaps, I don't know, 7-figure swaps and above, it probably pays to spend a lot of time figuring out the ideal process. For the shrimps here like me, maybe it doesn't take as much time to figure out if you'll lose 1 cent here or there. So yes, it is a good practice to do that.
So one more question about your experience. Do you know some good kind of frameworks? So you show just great things like to check like minimum, maximum price and all the rest, but maybe there is some frameworks how you can integrate Chainlink like easier to don't think about this like manually. Or probably you know some other protocols that already implement that we can see their code if it's open source.
Yes, I will go back to that code you're referencing. This can get a little tricky because although most of these checks are straightforward and most likely everyone will implement them, the second to last line, dealing with the Oracle staleness threshold, this one potentially could be a variable that you want to configure yourself. So if you are highly sensitive to price changes, you may want to set this threshold to a lower number. But at the end of the day, yes, I think you are perfectly right that Chainlink or some other integration should be handling round ID, price, and max answer, min answer checks. So yes, if anyone knows of a solution, please do share. I don't know of one at the moment, but it's a great idea.